All right, hey guys, we're going to go over the sine, cosine, and tangent practice sheet. These are just important trig functions to know. We're going to be using this a lot, right? So I'm just going to go ahead and work through some of these problems with you. I won't do all of them because you do one, you can do them all, really. So again, like I was saying, these are all trig functions. Trig functions. And when we work with projectile motion, we're going to use these. This is really important to know. And if you don't really get this, watch the video again, but I'm going to go through like what each function does. So a little quick lesson. If you guys know this, have taken geometry or trigonometry before, you should know this. SOHCAHTOA, which explains what each of these functions does. So for the sine, the sine of an angle is equal to its opposite over its hypotenuse. So this little diagonal right here, that's called the hypotenuse. And if we're looking at, say, question number 1, for example, it's telling us what's the sine of angle C. This is our angle right here. This is angle C. Our sine is going to be our opposite. So it's the opposite right there. So 21 over 29. So sine of C is equal to 21 over 29. Right? Our cosine right here. Sorry about that. Hit the camera. Our cosine of an angle is going to equal, so how sine was O over H, cosine is A over H, so that means adjacent over hypotenuse. So our cosine theta, so this right here, this means angle. This theta is a Greek letter, it means angle. So cosine of angle equals adjacent over hypotenuse. If we want to look at, say, number 3 right here, so our angle is C. The cosine is C, so cosine is equal to 36 over 39. Cosine of C is equal to 36 over 39. And you can, it says to express the fraction in the lowest terms, so really that fraction is going to end up being 36 divided by 3. Is equal to 12, and then 39 divided by 3 is equal to 13. So the answer to this will be cosine of C is equal to 12 over 13. Very simple, very easy. And then lastly, our tangent. So TOA, our tangent, theta, again, theta means angle. Our tangent is going to be opposite over adjacent. This is when you don't know the hypotenuse. It's the tangent of theta. So then again, if we look at number 5 right here, tangent of A. So it's going to be our opposite angle over our adjacent angle. So again, this right here is the adjacent. That's the opposite. So now tangent of A will equal 12 over 35. So this is just to get familiar with each of these functions and how they relate to this triangle right here. And you'll be seeing these right triangles a lot with projectile motion, and it's really how we solve each of these projectile motion questions. Flip it over to the back and start getting used to how to plug this actually into the calculator. So it's asking us to find the value of each trigonometric ratio to the nearest 10,000th. That's just basically 2 decimal places. So first thing I want you to make sure is that your calculator is in degree mode. Some of you at home might be using the big calculators, the graphing calculators. Make sure it's in degree mode. It might be in radian. If it's in radian mode, you're going to get the wrong answer. So, and really we never use radians in physics. So if you have one of those big fancy calculators and you're doing physics, first thing you should do is press the mode button and then make sure it's in degree mode. So then on these calculators, it's very simple what you want to do. So let's look at question number 7. It says sine of 62 degrees. For these calculators, all you want to do is press 62. Press the sine button, and that right there is the sine of 62. So that's going to be 0.88. And again, this isn't in degrees, right? That's not degrees. That's just a number. It's just asking for the value. So let's look at cosine right here, cosine of 60. Just type in 60, press cosine, and you get 0.5. And now let's look at tangent. So tangent of 79, so 79 tangent, we get 5.14. And yeah, you guys don't have to do these through here. Don't worry about that. I just want you to do the first 12 problems. Use this video, go back and rewatch and look over this. And maybe another quick point right here. With projectile motion, and I'm going to use this down here to draw a picture, right? So projectile motion means something is fired at a certain angle, so it'll go up and it'll come back down. So that's a really bad line. It'll go up and go back down. This is a rough outline of what that trajectory looks like. There, you can make this imaginary line right down the middle. Okay, and just here's an example problem. This will be good to watch and good to work through. Let's say this angle is 25 degrees. And we'll say we know that the projectile is thrown at an initial velocity of 8.2 meters per second. So that 8.2 is going both up and down and left and right, okay? And really what you see here is an X and a Y axis, if you guys are familiar with this. So this is your Y axis right here, and this is your X axis right here. You have an initial velocity, but you need to find your velocity in both the Y and the X axis. So the way you would do that is by using these trig functions. So this right here is our hypotenuse. If we're looking for the Y velocity, which is right here, we want to find our velocity going straight up and down, we would use sine. We would use the sine of, to find this angle right here. So if we set it up like this, if we set it up sine of, and we'll write our angle in there, 25 degrees is equal to opposite, so we'll just put V right there because that's our opposite, over 8.2, which is our hypotenuse. 8.2. So then to get our velocity in the Y direction, we just do 8.2 times sine of 25 degrees, and that'll give us our answer. And I'll go ahead and show you how to do this right here. You do 25 times sine, you multiply that by 8.2. That's going to give you your Y velocity, 3.47 meters per second. Conversely, if you want to do it in the X direction, it's going like that. This right here, well, that's adjacent. The sine was opposite, right? The Y was opposite of this angle. Now the X velocity is adjacent of this angle. So we'll just set it up again. We can do cosine of 25 degrees is equal to adjacent, so our V over 8.2, we get 8.2 times sine of 25 degrees, or cosine, excuse me. Cosine of 25 degrees. So 25 cosine times 8.2, and we're left with that 7.43. 43 meters per second. Go back, rewatch this as many times as you need. This is just a quick lesson on using trig functions in physics.